Hello and welcome to my session in the festive tech calendar. It's Christmas time. There's need for statefulness even for functions. So grab yourself a cup of hot or cold beverage, tea, coffee, perhaps some Glühwein, and let's enjoy this session together. Now, before we start, let me shortly introduce myself. My name is Christian Lechner. I am a development architect working at SAP, the company that you probably know from the very famous programming language ABAP. But we will not talk about SAP within this session, so don't be afraid. Now, I also have the honor to be part of the Microsoft MVPs. And with that, I really love serverless and I love a lot Azure Functions. And this will have something to do with the session today. Now, if you want to reach out to me, the easiest way is via Twitter. So here is my Twitter handle. It's LechnerC77. I'm also available on LinkedIn and Polywork. But the easiest way is Twitter. With that now, let's start with the show. And let's see what's hidden behind the title. So as it's Christmas time, we have Santa having to gather all the wishes of the children, right? Now Santa wants to become a bit more digital, and he would really like to have a digital Christmas wish list. So he would like to have at least some APIs and maybe also some UI where children can use their mobile in order to send their wishes to Santa Claus. Okay, I think we can do that, right? So let's see what are the requirements that Santa has for that. So Santa, what do you want from a business perspective? How should this wish list work? And do you have also some other requirements that we should be aware of? So let's start with the basic stuff. So basically, what Santa wants is some APIs for wish lists in order to, interact with either on UI level or even on pure API level with children or maybe even adults that have wishes. Now, there is some constraint that he wants to put on that one. He wants to have a maximum of 3 wishes per wish list. Okay, that's something we can do. There's no rocket science behind that. And of course, as during Christmas time, there might be some load on those APIs. They should be capable to handle this load decently. So he doesn't want to have any downtimes or something like that due to unexpected load. So, taking a look at that, I would say, that's something that we can solve with Azure Functions. Because they are perfect for doing APIs. We can put in any code there. We can even also store data via Azure Functions on a persistence layer or using durable functions or something like that. And they're definitely capable to handle the load, of course. So that's good. So I think that's the direction. What else has Santa Claus within his bucket? He wants to have all the stuff running air-gapped. So he doesn't want to deploy all those things into a cloud. He wants to have that within his own data center, which is huge. I'm quite sure. Okay, so that's something that's to cover. Azure Functions might be difficult. I would guess that we are somewhere with microservices and Kubernetes or something like that in order to handle the load and in order to have this thing going. Something to wrap your head around. Is there something else that we should know that we have to take into account? For example, with respect to the developer experience, because somebody has to implement that, maybe the little elves that Santa has, or maybe even Santa himself wants to do some code. So is there something that we have to consider from that direction? And Santa told me, yes, there is. There are 2 points. First, the development should be as easy as possible. So he doesn't want to have to do too much with YAML files and diving into the depths of Kubernetes. That's what he told me. That's cool. Very cool to bring that together with the air-gapped scenario, right? As he saw that Azure Functions are quite cool, he said, at best, the development experience should be as we know it from Azure Functions. So we are now at some point that is really funny, because we have to take into account the air-gapped scenario, and on the other hand, we should at best be something like Azure Functions. So that's funny. So the question is now, can we solve that? Can we solve that at all? And if yes, how can we do that? And from my perspective, that basically boils down to, let's say, 3 questions to start with before we even start with implementing something. So can we even use Azure Functions outside of Azure? Is there some strong entanglement with Azure from a legal perspective and also from the perspective of how to deploy that? So basically, can we even run, if we are allowed to run them outside of Azure, can we run Azure Functions as containers on Kubernetes? That probably would be the solution for this scenario to some extent. And even if we can do that, how can we handle the state of the wish list? I mean, we could do that easily within Azure, because there we can use all the things around durable functions and durable entities that would help us there a lot. But can we do that outside of Azure? First, before we now start really going into the code, let's take a look if we can solve that. And well, I did my homework, so I prepared the references here for that. Let's start with the question, can we run Azure Functions outside of Azure? Are we allowed to do so? Now, Azure Functions as a service offering is of course available on Azure as a managed offering. But Azure Functions are open source as of day one. So taking a look at, for example, here I have the Azure Functions core tools, which is really, well, the core tools with the runtime. Taking a look at the license, it's the MIT license. That's good. So it's really open source. Of course, there is some governance process of Microsoft around that, but we can use that also outside of Azure. Okay, that's good. That's good. Now, as these are the core tools, maybe we also find something around Kubernetes. So let's scroll down a bit and let's see if somebody else already had the idea to deploy functions on Kubernetes as containers. And yes, Azure Functions can be deployed to Kubernetes as Docker containers. And that's really baked into the functions environment and also baked into the core tools. So what you have to do in order to create some predefined Docker image, you can use the func.cli in order to create that file. So you do not even have to do that manually. So that's good. So we can now run functions outside of Azure, and we can run them on Kubernetes. There is even more documentation on that one that I found when Googling around. Having said that, we will later see that there is quite some room for improvement for this documentation, but I don't want to spoil anything. Now, the next question is this state handling. Now, that's really a hard one. That's a tough one. Within Azure, as I said, I would probably use durable functions. And they have some dependency to storage, of course, because there is no black magic to handle the state. You have some storage there, some storage providers. And Azure Functions have some storage providers. So they came some during this year in addition to the classical one. So let's see if that helps us to some extent. So let's take a look at the different storage providers, because maybe we can use this durable functions or durable entity functionality with Azure Functions, which would be perfect. So this would really then be Azure Functions on Kubernetes with all the nice and cool stuff. So let's check. We have the storage provider Azure Storage, which is Azure Storage. Okay, that's a no-go. We have the storage provider Netherite. That's a new one. It's relying on Azure Event Hubs and an Azure Storage account. No, that won't work. We have this dependency to Azure, so no air gap scenario there. And then we have MS SQL. Okay, so we could do a SQL server that we can use as a backend. But that's quite heavy stuff, right? Can't we do that a bit more lightweight without deploying a SQL server with all the stuff around that? Let's go one step back. What would we have done if we would have done just microservices on Kubernetes? We would not have started from scratch, right? We would have used some libraries or something like that in order to make our life easier. And maybe we can do so also for functions. So the best thing to start there is Dapr. Dapr is short for Distributed Application Runtime. And the goal of Dapr is, in a very modularized fashion, to simplify, as is stated here, the cloud-native application development. So what Dapr is basically a so-called sidecar library. So Dapr will be injected within your pods on Kubernetes in order to handle all the heavy lifting around cloud-native applications. So let's check what's in there. So as we can see here, Dapr helps us to build those applications and also on-premise. So we can really do this air gap scenario. So what are the building blocks there? So we have service invocation. Okay, that's nothing that we need. We have state management. That's perfect. So build resilient stateful services with your state store of choice. That's cool. That sounds like a plan. So we have some stuff more that's available with Dapr, but we don't need that at the moment. So we have the state management. That's good. Now, nevertheless, there are now two questions for me. Of course, we can basically call Dapr from our Azure Functions, because if we can do that from microservices that are implemented in any language, TypeScript, whatsoever, we also can do that from Azure Functions. But we love Azure Functions, and I think also Santa loves Azure Functions, because you can use something that's called binding. So all this SDK dance that you usually have to do in order to connect to, for example, a state store or database whatsoever, is hidden behind those bindings. Now the question is there a binding for Dapr available for functions? Because that would make our life really easier and would help Santa in his goal to have a really decent developer experience. And the good news is, yes, there is one. So we have an Azure Functions extension for Dapr. Now, basically, what we probably need is we need a binding in order to read data from the state store. And we need a binding to write data to the state store, right? So we have a wish list. Somebody asks us, hey, what's on my wish list? Do I have still a wish free? So we have to read it. And of course, you want to put wishes on that list, right? Yeah, so let's check that out. Blah, 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 blah. And triggers, no. Function bindings. Okay, that's what we are looking for. And here we have an input binding for Dapr state. That's good. And we also have an output binding for Dapr state. So that's even better. So we can use this binding functionality, which is really, as you will see in a few minutes, decent for getting things started. That's cool. Now, as a state store, we are running, well, is there something that might be used with Dapr? So I don't want to go for a heavyweight database. Let's check the documentation of Dapr in order to know what can we use as a state store. And looking at that one, we can use Redis as a state store. So we can simply install Redis as a state store and then get things going. Okay, that sounds good to me. So so basically we now have at least the ingredients together for our magic Christmas wishlist potion in order to get things going. So we probably will rely on Kubernetes in order to implement the AirGap scenario and to have all those resilience and stuff around Kubernetes. We will use Azure Functions that we can deploy in Kubernetes. We will use Dapr in order to do the state handling. So we have to install Dapr on the cluster, and we have to install Redis as a state store on the cluster. Okay. So yeah, then that's what we have to do. So we have to do that AirGap. That's something we must not forget. So I will not go now to Azure and deploy an AKS cluster. That makes no sense. So we should do that locally. So the question is now, how can we do that locally? And this will be, well, the very first part now. Let's see how we can set up that stuff locally using a thing called Ranger. And let's start with installing the Redis store. So that's the first thing that we will do now in order to make our hands a bit dirty with code. Okay, so let's get things started. Let's first set up our local Kubernetes cluster. And for that, as I said, we will use a thing called Ranger Desktop, which is really cool. It's a very slim, very lightweight way how to set up a Kubernetes cluster locally. Basically, what you have to do is to install Ranger Desktop on your Mac, on your Windows machine, or on your Linux machine. And this will spin up a K3s-based Kubernetes cluster for you. And with that, we can then deploy all the stuff there. And what you will see here on a Windows-based machine is basically something like this little thingy here, where you can see what's the version. And you have also your Kubernetes settings, so you can use different Kubernetes versions and some other things that you can configure here. As I said, very streamlined, very easy to use. So I have already installed that and I already have it running. So as you can see here, we have our default namespace and we have some kube-specific namespaces with the corresponding functionality behind that. Now, first things first, let's install Redis, which is our state store. And for that, I will shortly do jump to my cheat sheet. So we will now use Helm in order to install that. So let's first add the repo. It's already there. Let's do a short update so that we are on the latest state. Nothing new for there. Happy helming. So let's install Redis. We will now not do around with namespaces here for the sake of this demo, so it's not production ready. So there is some things that we have to do for Center, and yeah, that was it. So Helm installed the Redis deployment, which will spin up Redis within our cluster. So what we can do now is we can check that by kubectl get pods. So we should see now some pods with respect to Redis. So as we can see here, it's slowly starting up. This takes a few minutes. So as you can see, the master and the first replica is already up. So we are good to go from here. So basically with Redis in place, we can now install or start with the next step and install Dapper to our Kubernetes cluster. Okay, so let's continue, and let's install Dapper now. So there are two ways how you can do that. You can install Dapper via the Dapper CLI. So you first have to install the Dapper CLI, which is really straightforward, and then use the Dapper CLI in order to get things going. Or you can also use a Helm chart in order to install Dapper. We will now move on and install Dapper via the Dapper CLI. So we paste in the command via Dapper init. Make sure before you do that you are on the right context. So I'm using my Ranger desktop in order to deploy the Dapper control plane to your cluster. And what this will do now is it will set up all the things around Dapper that you need to do all those building blocks and those sidecar injections. So what we can do now is we can do Dapper status -k. So as you can see here, all the infrastructure is running. We also have a dashboard that's running here. We have this sidecar injector that will inject the sidecars to our pods. So we are basically good to go to make the first thing that we need to do now. So we have Redis installed, which will be our state store, and we have Dapper installed. Now, the first thing that we now need to do is we need to wire those two things together. So we need to tell Dapper, hey, please use Redis as a state store whenever there is a request for that. And in order to do so, we of course need some YAML files for that. And it's quite straightforward. So what you do there, and if you're doing Kubernetes, that's really nothing surprising for you. We will deploy something that's called component, or we will apply something that's called component. And we give it the name, we call it state store because we are not that creative. And we tell Dapper that this is a state store of the type Redis. So Dapper will shield or will kind of abstract the different options that you have with state stores. So you can also use other state stores for that, be it on AWS, be it on Azure, be it within your cluster with a locally deployed Redis whatsoever. And this is something that you have to tell Dapper, of course, in order to make it aware of how to handle that. Now, with the deployment of Redis, we did not change anything, so we can go for the default values. And when we deployed Redis via the Helm chart, there was also a secret created. So if we take a look at kubectl get secrets, we will see that there is a Redis secret that we use now within this file in order to enable Dapper to talk with Redis. So what we do now is we just apply that file. So let me go to the right directory. Okay, and what we do now is kubectl apply the file, and what we want to do is we want to apply the state because we want to use Redis as a state store, right? So let's do that. And basically what we can see now is we have a component called state store that's now available within our cluster. That's good. So we have now Dapr, we have Redis, and we have brought all those things together via this component. So basically, we have now the foundation in order to start with our functions, right? So we can now start implementing our functions and then deploy them to the cluster and make use of this Dapr magic. So I would say, let's do so. Okay, so next thing that we have to do is we have to create our functions. Now, I have already prepared that because that's quite some work to simply get the setup. So I don't want to bother you with that. So basically what we want to have is we want to have three functions, right? We want to have three endpoints. We want to have one endpoint where we can query our wish list and see what wishes are on our list. I call that function a wishlist report. Then we want a second function where we can post our wishes to in order to bring them onto the wish list, which I called wishlist message. And then probably we also need some management API in order to clean up a wish list. So whenever we messed something up and we want to start from scratch, and that's hidden here within the Dapper management API. For the setup of those functions, I used the Azure Functions extension for Visual Studio Code, and I'm using TypeScript as a programming language. Dapr, as well as Azure Functions, support a lot of languages like, of course, C#, JavaScript and TypeScript, Java, PowerShell. So you really have the freedom of choice what to use there. I, however, will use TypeScript for this session. Now what I did is I simply created HTTP triggered Azure Functions and scaffolded my project with those. Now, as we said before, we want to use the Dapper extension for our Azure Functions. So what we need there is now also to have those extensions available. Now, for those of you who know more about Azure Functions, there is a very handy mechanism for that that's called extension bundles. And that's there by default if you use this extension, for example, which tells the Azure Functions runtime, hey, whenever there is a request for an extension like a Cosmos DB binding or something like that, just go to a specific place and fetch this extension for me, bring it in, and you as a developer do not have to care about that one. Having said that, Dapper functions are not part of this extension bundle mechanism. So what you have to do in order to enable them is to install them manually. And that's a two-step process. First one is the host.json should look something like that. You can even remove that one with the logging. There is some section about extension bundles that you have to remove in order to allow a clean install. And then you can use the Azure Function core tools, namely the func.cli, in order to install the extension via func extensions install. And this will then create this little csproj file, which then contains the references, as we have here, for the Dapper Azure Functions extension, which is currently still in preview mode. So as I said, hopefully there will be a bit more love around that extension because it's in preview mode for quite some time now. But that's how you would install it. And then it's available in your Azure Function as any other extension. Okay, then let's go to the code. So let's start with the easiest one, the wishlist report. We want to read from the state store the information out and return it to the caller. The caller will trigger this function via an HTTP call. And taking a look at the configuration of the function, what we will see here is, yeah, we have a function that gets triggered by an HTTP call. And we also will define a very specific route for that one, which is wishlist info. And this route should also contain an obligatory key that will be handed in, which is basically the name of the person that the wishlist belongs to. And then we will use the input binding in order to read out the information from the state store. So that's basically the nice thing here. So the extension will kind of wrap the handling, the interaction with Dapr in order to read the information from the Dapr store, from the Dapr state store. So we say, hey, dear Azure Function Runtime, this extension is a so-called Dapr state extension, so please use the corresponding SDK. The direction is in, so I want to read something out of the state store into my function. I have to give it a name, of course, because otherwise I cannot address it within my code. I have to hand in a data type, which is always string. It also works without doing this data type, but that's how documentation proposes it. And then, of course, I have to tell this extension how is the state store called. And as we said before, when we create, that's the name of the component. So as we created before the component for Dapr, we called it state store. This is the name that we have to reference here. You can have multiple state stores, but you have to address the right one. And then, of course, we have to hand in the key because the SDK has to read some entries there. And we simply transfer that from the route to our function. And that's all we have to do for this simple function in order to wire things up. And the code is then also not really complicated due to the fact that we use this input binding, because we can now address this input binding simply via the context parameter. So we do not have to do any, as I said before, SDK dance in order to get the credentials, call the right SDK in the right way. We just do that. And even if you would change the state store to a different one, not Redis, something else, our code remains untouched, as does our configuration within the function.json file. So we can always rely on that. All the complexity, and that's, I think, the beauty of the solution, is shielded or abstracted by Dapr. So what we do is now a very complicated coding, so super rocket science, no, just kidding. We check if there is something within this binding. So did the extension read something or not? Because maybe there is nothing on the wish list yet. If there is something, we hand back what's stored within the wish list. And as we can see here, I said, okay, I have a wish counter, which represents the number of wishes on your list. And I have wishlist items, which is simply a string containing the wishlist items. And if there's nothing to be read from the state store, we just return a default string. Okay, that's the easy one. That's the reading one. Now let's check the one that is of more interest for us, of course. That's the one where we post our wishes for Santa. And what we have here is, again, an HTTP triggered function. You now already know the game. So we have a route where we hand in the key. The method that we this time use is a post method. So we will hand over our wish via a JSON body of our post request. And we have the well-known thingy here, which will read the information from the wish list, because we have to check, are there already more than 3 wishes on, or are there already 3 wishes on the list? And we try to put on one further one. Or is there still room for wishes? So we will use here the input binding. And then, of course, we want to write the new wishes to the state store. And for that, we will use the output binding. That's the same mechanics. So we say, hey, dear Azure Function Runtime Extension Magic, please use for this extension, again, the Dapr state. This time the direction is outwards. So I give that to you and you store that into the Dapper state store. I do not care how, but you do that, okay? We give it a name in order to be able to address it. And of course, we also have to tell the extension, the name of the state store, the name of the Dapper component, and the key that we want to address. And that's basically it for this function. And of course, we have to put in some code there where we use the input that we get from our request and where we use the binding. So as you can see here, it's again very, very easy to implement that because you can really focus on your business logic, on your how. And that's also what Santa wanted, right? And you do not have to think about, oh, how do I read that out of the state store? How do I write that back? So we can again use this binding magic. So we check, is there something on the wish list? Using the input binding. And then we check the wish counter and we say, okay, I want to have one more. And if the wish counter then exceeds the number, we say, sorry, but you're out of luck. We have to say to you that you have already 3 wishes and we will return a corresponding status code. Maybe you know that one. And if not, well, then we add the new wishlist item that we fetch from our request body. So that's the stuff that comes in. Of course, there should be some error handling, but let's not be too curious about that. And then what we do is we simply fill our output binding. So as we had this wishlist out. So if we take a look at the function.json, we have this wishlist out that we now use here in order to provide the values for the wishlist counter as well as for the wishlist items. And that's all we have to do. Nothing more, nothing less. So here is the response body. And that we provide then. And if there is nothing on the list, I have some different handling and have some special mesh message for the caller. And then we will simply return the context and return the status code and the response body to the caller in order to inform him if there was a problem or if the wish was added. And as you can see here, really, it's super easy. And you do not have to wrap your head around interacting with Dapr. Now, having said that, extensions do not aim to, let's say, cover all the cases that an SDK would enable you to do. So when you think about Dapr, you can do a lot of things that go beyond reading from the store and writing to the store. For example, maybe you want to delete all the entries that belong to a key. And that's something that is not in the scope of the extension, and that's true for every extension. So there are limitations also for the Cosmos DB binding. There are limitations for the event bus binding and so on. That's okay. So what we have to do in order to implement this last function is we now really have to do the interaction with the Dapr SDK. But as you will see, that's also not very complicated. So configuration-wise, we now really have just an HTTP triggered function, which supports the delete method. And we specify a very dedicated route for that one. Again, we hand in the key to know which wishlist to delete. And from the code perspective, we now have to import, of course, the Dapr client in order to interact with Dapr in a more convenient way than just calling URLs. You can also do that, but I will not go down that path. And what we will do now is we will call the corresponding endpoint for the state store on the Dapr client. And what we have to do is, well, of course, from the binding data, we fetch the key. that we get from the route. And then we define some attributes, namely the Dapr host, which is localhost, because we have the sidecar injection. So Dapr sits within very near to our container. And the Dapr port is also available as a process environment if we inject Dapr as a sidecar. Then, of course, we have to tell the name of the state store as before. And then what we have to do, and as you can see, that's also not very complicated, but it's more to do than just doing binding. We instantiate the new Dapr client with its corresponding host and port. And then we just say the Dapr client, hey, please go to your state store and delete on the state store that I have specified with this name, so on the corresponding component, the entry with this key. And yeah, that's basically it. That's all you have to do. So as you can see here, even calling Dapr via the SDK is not super complicated. But it's already more than just doing binding, because from my perspective, that already a bit clutters your code with, I would say, infrastructural code that has no value for your business logic. Now, with that, we have implemented our functions. So we have the code. The next thing that we would have to do, as we have seen within the official documentation, is we now need to create the Docker image and push it to a Docker registry. You can scaffold the Docker file via the functili, as we have seen before. So we have it here. Yeah. So we can do a func init -- docker only, for example. Which is true for existing projects, which will then just create the Docker file and the Docker ignore file, as we see here. Now, the default Docker file can work, but I would recommend to exchange, if you're working with TypeScript or node-based projects in general, to exchange the base image to the Node 14 version, which is the current up-to-date version. Because you might run into problems with the default version when it comes to using specific SDKs like the Dapr SDK. They expect some specific features that are only available with Node 12 upwards, and I took Node 14 because that's the standard one. Then in addition, what I changed is I set one environment variable for this demo, which is unfortunately also not documented, which tells the Azure Function runtime on which port to expose the HTTP trigger function. Yeah, and that's basically it. You have to build your Docker file and then push it to the registry of your choice in order to make it available for your Kubernetes deployment. And that's where we go next. So we have now our Docker files built and pushed to the registry. I did that before. There is no real rocket science around that. So it's really easy. I usually use a makefile. So you can build your image, push your image, and that's it. So there is nothing special around that. Now, what we, however, have to do now is we have to, of course, deploy the container to our Kubernetes cluster and then use them. And when we deploy the containers, we also have to tell Dapr, hey, this container is something where you should inject your sidecars because we want to make use of all these nitty-gritty things there. That doesn't come out of thin air. So in order to do so, let's take a look at the corresponding deployment file. Where I have two parts in there. I have, of course, a deployment, which deploys my app, which is the wishlist app. Most of the stuff is as usual. So I specify my container that should be fetched, and I specify the ports. And there is now one thing that is specific for Dapr. And this stuff tells Dapr how to interact with the container. So first of all, this tells Dapr when this container gets deployed and when the pod gets created, inject your sidecar. Then I have to tell Dapr how I will call that app from now on. This is the app ID in order to be able to interact with Dapr. And then I also have an app port that's not necessary for our scenario, but yeah, does also no harm if you specify that one to tell Dapr which port is exposed. And then, of course, I have also added a service for my wishlist app of the type load balancer, which will then be available within my Kubernetes cluster. And with that, I am set to deploy my functions that I have within Docker Hub. So I have I have packaged those 3 functions, and I can use them now by applying this file. So yeah, let's do that, right? So let's go to the right folder. So I have here my Kubernetes folder, and here I have my files in there. And as you can see, I also made a typo that I just see right now. So that's a kind of deployment. So what I do is now I do kubectl apply -f, and I use this misspelled file. And well, now things are happening. So the deployment takes place. So the container gets downloaded from the Docker Hub, the sidecar gets injected, and the service gets created. So if we now take a look at the get pods command, we see now 2 new friends here. We have this load balancer service that is already up and running, and we have our wishlist app, which is up and running. And as you can see here, it's not just the container that we have specified, but it's also the sidecar that got injected, right? That's also there. So now let's do one more thing, and let's do a port forward now in order to be able to. No, that's not what I wanted. In order to be able to access our service. So first things first, I will now go to localhost 7075. And what we can see already, because I did not switch that off, is I see that there is a function app up and running within the Docker container that is running on my local host. That's already good. That's a good sign, because now the function runtime is already up and running. Now let's do our HTTP requests, and let's see if things work. So for that, I use an HTTP extension that I highly recommend when using Visual Studio Code, which allows me to define all those nice requests and enables me to fire them right from VS Code. So let's check if I have a wish list already available. So let's send the request, and we get a 200 OK. And there are no wishes yet there. So I have 3 wishes available. Okay, so let's start. First of all, I want an Xbox. Okay, I have my first item on there. Then I want, well, some Lego, I don't know, I want a Star Destroyer. I will not get it, but at least it's on the list. So yeah, it has been added. And something else that I probably will not get is a Surface Duo, for example. Okay, also this one was added. What else can I have? Let's say I also want a MacBook, maybe. Let's see. Oh, okay. I have my right response code. And, well, sorry, you already have 3 wishes on the list. Okay, really? Let's check that. Yeah, I have my Xbox, I have my Lego, and I have my Surface 2. So I have already 3 on my list. Okay, so state store works as expected. So now if I would say I am, let's say Gregor, and send the request, yeah, I get that one. So let's see. Yeah, I have one. Yeah, that works. Works like a charm. So let's see if also our management API works like we would expect that. So we have here also our management API where we use the delete. And I will not delete well, I will delete Gregor's list. So I sent the request and okay, the state store for key Gregor is deleted. So there should be now no more wishes on that list. And yes, that's true. Let's also clean up mine just for the sake that we see that it works. So we see, okay. Okay. Clear again. Yeah, that's cool, right? So we did quite some stuff, right? And I think we really made it happen what Santa wanted to have. So let's shortly check. Let's jump to a short summary. So what did we do now? We well, wrapped our head around a lot of requirements that Santa has with all this air gap thing and that great functionality that he wants to have. So what we did is, well, we set up a local Kubernetes cluster using Ranger Desktop, which is really super easy. So you just download it, install it, and it's running. And on Windows using WSL, it's blazing fast. Then we installed Redis as a state store that we used there. And then we installed Dapr. So that was also quite easy. So we had the Helm, we had the Dapr CLI that we used in order to install Dapr. And then what we did, we wired up Dapr and Redis. So we used this component functionality that comes along with Dapr to tell Dapr, hey, this is the state store. You know what you have to do. Then we created an Azure function for the wishlist, or we created 3 Azure functions, and we made use of the Dapper extension. Then, with that in place, we basically built. So let's assume we built. I built that at some point in time and deployed the Docker images of the functions to our local Kubernetes cluster. When we deployed that, we told during the deployment or within the deployment file that the functions get an annotation that tells the deployment and tells the Dapper management plane, please inject the sidecar. Please inject the Dapper sidecar. And with that, we could easily use the Dapper extensions within our functions. And then, well, as usual, we tested the stuff. So we exactly achieved what Santa wanted. So Santa should really be happy now. We have implemented this air-gapped scenario, making use of Azure Functions. And so the developers do not really have to wrap their head around in depth what's happening within Kubernetes. They can just build their functions, deploy them, everything's fine. Now, of course, there is always more things to take a look at. And as an outlook, well, maybe it would also be worth looking at Kida. So event-driven autoscaling within Kubernetes that we could wire up with functions. But, well, maybe let's do that the next time. With that, yeah, we are through with today's session. Hopefully Santa is happy now. Hopefully we get all our wishes from Santa. And well, I thank you very much for watching this video, for your attention. I wish you a very fruitful and nice rest of the festive tech calendar. A lot of new additional interesting sessions that you can watch. I wish you a very, very nice Christmas and a happy new year. See you in 2022 again. Until then, stay safe. Bye.